computer. And here is the lab. I didn't post it yet. UNIX Lab 5, write a mini shell. Your mission is to write and run a shell. Your program must loop doing the following. Display a prompt on the screen. Receive any shell command from the user, including parameters like ls-l file. Did we do this? Did we start doing this?
No, we haven't spoken about anything about it. You only mentioned that we're going to have a homework where we're going to write a mini shell.
Yeah, so here it is. I thought I started programming it with somebody. Maybe it was a different group. Anyway, carry out the command using exec v. I'm going to get rid of exec l, not exec l, just exec v and fork. Your shell must wait for its child to terminate before displaying the next prompt. Exit loop upon receiving the string quit. You must find the location. No, so let's add this. In order for exec v to work, you must find the location of the particular shell command requested by the user. I didn't show you how to get the shell? How to get the path?
No, can you just show us?
Yeah. This can only be done by looking for it in all of the addresses in your environment, spelled wrong, right? Environment variable path. You will need to use the getEnv function in order to get the path. In order to separate the various libraries in it, you must use the string toke function. If a given command was not found, display an error message on the screen, such as command not found, and return a prompt. This exercise may be done in pairs. Okay, so maybe you didn't understand that, but
Pairs, you say?
what?
Pairs?
Heaven forfend.
So, fun with...
do you see my black screen here?
Yeah, we see.
Stop share, share, that share. Okay, so here I can do SSH into linap.jct.ac.il. I can also use PuTTY from Windows to do that, but I can do this.
Is it blurry for anyone else?
It's blurry?
Now it's not as bad. No, now it's good actually.
Okay. Wait, do I have anything with? Oh yeah, there I have my practice shell. Who did I do that with? I guess I did it with the girls. The girls get more, they get a better class, I have to tell you. Because they participate more. You know, life is like a sewer. What you get out of it depends on what you put into it. So let's just look at what I did with them. Practice, Emacs, practice, shell. I think I bored them because I hate these colors. How do you, Abraham, how do I get rid of these colors?
He's not with us anymore, but I think you have to go to options, hit options.
Yeah, but I can't.
Yeah.
Colors bother you, or you guys can see it anyway?
I'm
I
fine
don't
with
see
it.
colors
I'm
right now.
color.
Before I saw
I don't
colors.
see color. Oh, damn! I killed the joke.
Yeah, now I see colors.
See it? We can see it.
Bothers you? No, it's readable? Okay.
It's
For
readable.
me, it's not so readable. So
The dark purple's a little hard on the eyes.
these are a bunch of includes that you have to figure out what to do. Then I made some buffer. I made some variables here. I always, by the way, in my programs, I define everything at the start. In other words, I make all my arrays and all my variables at the beginning, because in the old days, that's the way you had to do it in C. But I don't know if you still have to or not, but that's the way I do it. And maybe you do. I'm writing in C here. Now I make here, since I already wrote all of this, I will comment it all out.
And are people still writing like Linux scripts and whatever scripts like extensions and stuff in C still, or there's like new stuff to use?
I don't know. Okay, so we do like this. Print Nachum prompt. Here, let's run this program. GCC practice shell. Now look at that. See how that compiled? Nothing. No messages. That's what you want. What if I do GCC minus wall? Then it gives me some errors. Ooh, the address of path will always evaluate as true. Uh-huh. See, that's good. Unused variable command. Interesting. So I have some little mistakes there. See, the wall gives me some errors. I should go fix those things. But before we do that, let's just do GCC practice shell, and let's run it. So prompt. I have Nachum prompt. You see that? And now I type, for example, something, ls, and it does, well, it doesn't exactly do ls, but it does something. What it does is print the path. Look if here, let's do Control C. If I do echo $path, look at the path here. What is the path? The path is the places where I'm going to look for a command. If I do a command like ls, like for example, where is ls? ls is in bin. Look at my path. Is bin in my path? Yeah, here's bin. I added some garbage to the end. I added ls ggg. Yeah, here. Oh, shut the door, please. So bin is one of the places in my path. Look, see, let's look at the path over here. See how it says user local sbin, then it says user local bin. Eventually it says sbin, then it says bin. These are all the places in the path. Now, in order to run something like, for example, ls, what I'm going to have to do is create a string like this, bin, slash bin slash ls. In order to run it, I got to give the path, which means I have to combine one of these paths with the letters ls, with the name of the command. So the first step is to be able to cut up the path. Also look, understand that when I run my practice,
Why can't we just use the where is?
because that's using the shell.
Oh, where is part of the shell?
No, where is actually a command. Why can't you just use the where is? Yeah, how you could run the where is, but then you'd have to get the where is, get the result of it, And you would still have to cut it up because where is, if you notice, gave us a bunch of things. It gave us ls with a colon. You have to remove that. And then you'd have to get this one. You know what I mean? You could maybe use which, but anyway, that's not what I want you to do. I want you could actually use where because it's a function. You could actually.
Actually,
But I
yeah,
want you
which
to
is
do-
probably better.
Yeah, which is better just gives you one result. So look, Nachum prompt, I type ls, I get something. I type ls, I get something. I type anything actually, I get something. So this is it looks like a shell. You see, it's like a mini shell because I'm giving a prompt, I'm typing something, and I'm getting a result and then a prompt again. It's kind of like I have a shell. Now, how did I do that? So Control C. Let's look at some of the features of what I've got here. So the first thing that I've got is this while one. This while one is what gives me my infinite loop. And then I do print f Nachum prompt. And then I do flush. That flush is just to make sure it prints. And then what I do is I read from 0, which is the standard input, and I put it into my buffer. And then I put at the end a 0 so that I have whatever he typed correctly. You know, with a 0 at the end, so it's really a string. And then I make a fork. Why do I make a fork? Because in the fork, I'm going to want to do an exec v. I'm going to want to do an exec v. I'm going to want to execute the command. But if I do succeed, if I wouldn't do a child, then exec v replaces the current process with whatever I command, whatever I tell it to run, and then it would die after it finished, and I wouldn't come back to print the new prompt. So what I do is I make a child. The child will run this execv, and then when he dies, it's no problem. The father will come and print the path again. And that's so I do so this if path, by the way, is pointless according to the compiler. So, but in any case, I print, and the father, wait, who is this? This is, what does it say? Nachum say command not found. Okay. Okay, that's something else. Anyway, this is just a print. Now, look at the father. This is the else is the father. The father is a wait. All he's doing is waiting for the child to finish doing whatever he's doing. That's so that when he prints the new line, it should, the new prompt, it shouldn't come out in the middle of the previous command, of the output of the previous command. So once the wait finishes, he goes back up to the infinite loop and he prints the prompt again and reads again, and then perhaps creates a child again. I mean, does create a child again. So that's the basic structure, is that I creating a child, he's running an exec, the father is waiting for him to finish, and then the father's coming back and printing the new prompt again. Now, the whole process of what the child does is complicated. The child has to get the path, full path equals get end path, in quotation marks. And then I copy the path, but what I do is I do a couple things here. I do string tokenizer, which chops up the path, the full path, by this symbol is what I would give it. And I gave it a symbol, which is a colon. So it's going to chop up the full path by a colon. And give me the first result in path. Yeah, this is a mistake. This should really be if the string path well, what is path? Anyway, fine. I'll fix that later. But the string, now I got one of the elements of the path by this string toke. So notice I call this full path. because full path means everything with all the colons and everything. A path is a particular path, like /bin, /sbin, whatever path I have. Now to that path, I have to concatenate the /ls, because that's the command that I want to put on. Now, in this case, I hard-coded the ls as the command. No matter what you type, it's always going to run ls. Even though I wrote code here to get the command, I didn't actually use it. I just, I was in the middle. I didn't finish. I was just testing it with ls. I just hard-coded the ls. And then I printed it just so that I would see what it is, the new path. And then I ran path with the array. What's the array? The array is what I defined it over here at the top, which is I hard-coded it again, ls minus l with a null at the end. I just hard-coded it because I wanted to just show that it works. And then what do? I run exec. If it succeeds, it will succeed and end the program and end the child. If it doesn't succeed, however, it will not end the child if it doesn't find it. So then I have to go into a while loop. And I have to do string toke again. This time I pass it the colon again, but I pass it as 0 here, which means continue on in the same path that in the same full path that you had before. You go to the next token and copy that to path, and then check the length of it. And if the length is not 0, then that means I got something. Then I just added to the path this ls minus this whole gibberish for no reason. I'm just really what I want to do now is another execv, which I do over here with the path. But I ruined the path over here. I added some garbage to it. And then I just printed it. The basic idea is that over here, I'm going to have to keep going through the path until I find the correct path and run it with execv. How do I know it's the correct path or not? Very simple. Anything that doesn't find it, the execv will fail and not exit my program. The minute I succeed, it'll run and then exit my program. So it will not continue in the loop. So I just continue the loop until I run out of paths. And as soon as I find a correct one, it will automatically exit. All right, so I have to stop for a minute here.